Hi everyone, welcome back to my class. Okay, so in the previous lesson, we have learned about the fundamental calculus, right? The integration, which is the opposite of differentiation, right? And also we study how to calculate indefinite integrals and also definite integral. Okay, so right now we are going to explore more about calculus in this subtopics. We call it as area under a curve, right? So this is interesting. So why we can measure or find the area of object under a curve, right? You probably understand before about how we can calculate the area of some polygons, okay? So you maybe can find the area of rectangle, let's say, right? Rectangle is very easy. You just multiply A times B, A and B, right? You multiply the area. And under polygon, let's say this, okay, the triangle. So the base of this triangle multiply by the height to get the area of rectangle divided by 2, like this. All right, now you might think that how we can find the area with shape that combining of straight line, the boundaries, the straight line and a curve. Let's say how we can find the area of this, for example. All right. So to find the area of this, we need to study the area of under a curve first. All right. So let's find out how we can find the area of this shape. All right. So let me first draw the shape in xy coordinate, of course, and then okay, like this. It's 2, 0. All right. How to find the area of this? Right. How to find it? It seems difficult, right? Yeah, it's difficult. That's why we need to study the fundamental calculus before, right? This one we can find by using the integration, but let me explain how it is happen, all right? So firstly, if you might think that to find the area of, maybe I will make it bigger. Sorry, it's too small, I think. Make it bigger then. Okay. All right. Let's do. And all right, so you know that this shape is bound by this function. This is the corner point of the shape. So the shape is like this, and how to find this area of this, right? So this shape is bound by this function. The function is x squared plus 2. And then we have the next bound is this fx here, or y. This fx in particular x, we call it at e. And then we have also the next boundaries, it's fx as well. It's bound by x equals b, and then these boundaries. Now, these boundaries actually is the difference between a and b, right? Or we call it as, let's say, the delta of x or we simply write down as dx. Okay. All right. Now you have to think like this. All right. We already know how to find the area of a rectangle, right? So suppose if we make a rectangle like this in here, like this here, so it will be a rectangle, and then if you can find the value or the length of this and the length of this is x and this y or fx, so you just multiply it, right? Now the problem here is the curve is not a straight line, it's not parallel to this x-axis. This is the problem. Now in calculus, in this concept, we need to make the rectangle. Suppose we can make any rectangle here, but the problem was always the same. Yeah, and then if you make it narrow, and then you chop this area until the only one slice like this, and then we get the idea. So to find the area of this shape, so you have to add every slice, this vertical line from A to B, right? We added the area, and this slice we can find the area of each slice by the area of rectangle, because we just simply multiply the base and the height. So this is the base, the delta x is the base, the base, and this is the height is fx. All right. So the area here, it will be the sum of, the sum we can denote as this notation. You know this notation is integrals, right? So basically integrals is the sum of the area under the curve, right? So the sum of the area, the base is dx, and you multiply by the height is fx, right? Fx times dx. So this is the area. You got it now? But we sum it each slice. So basically fx times d is the area of each slice of this. All right? And then you add it until you get from A to B. That's why the boundary is from A to B. All right? Now, here as you can see that the area of this shape is the addition of each slice, and then it's symbolized as or we formulate as this integration. All right? So integration of the fx, the height, times dx. You know that dx is the base, right, of this slide. Okay. And now you know that fx times dx is actually a derivative function, right? And derivative function in this notation summit, which means it's integration. So it's integration then, right? So it's integration. Okay. And then in order to find the sum, we no need to find every slice, the area of every slice, but we can using this, the sum using integration. Okay, so this area of this we can formulate as, right, it's become, you know that integration, the derivative function, if you integrate, it will be the initial function, or we call it the process as anti-derivative, right? So it will be f, big F, right, from B, because the boundaries is from A to B. It means, you know that, for example, if you want to find, let's say this is from 0 to 2 and 4. Now, this distance is actually is 4 minus 2, right? 4 minus 2. So the same, this one is B minus A. It's F A, like this. All right. Okay, now we got this formula of area under curve. Okay, so this is the formula of area under the curve. from the fundamental of theorem of calculus. Okay, and then let's find this area. Okay, we have this function already, x squared plus 2. So let's find this area from a and b. It's 2 and 4. Okay, 2 and 4. So fx we write as x squared plus 2 dx. Alright? So we can integrate this, alright, directly. So the integration of x squared plus 2 you already know, right? So it should be x cubed over 3, right? And then plus 2x. Alright, so this is the result of integration. Since this one is definite integral, so we can put the boundaries for 2 like this, and then we can apply this formula then. Okay, let's start with 4 first, I mean. So it will be x cubed over 3, 4 cubed over 3, okay, plus this one should be 2 times 4, okay, and then subtracted by 2, so it's 2 cubed over 3 plus 2 times 2. All right. So, okay. So the area it will be this. Okay, I can write to the left. Yeah, it's okay. Because we don't have the space to the below here, so we need to write to the left. So it should be 4 cubed. How many 4 cubed? 64 over 3 plus 8, and then subtracted by that one should be 8 over 3 plus 4, like this. Okay, and then we have here, we calculate fraction with integer. So 64 plus 24 over 3 minus 8 plus 12 over 3. Okay. And then here we have 64 plus 24, it will be 88 minus 20 over 3. So here this area it will be how many? 88 subtracted by 20, it's 68 over 3. All right, so this area it will be 68 over 3 units square. So this is how we can find the area of a shape that bound by the straight line and the curve. So that's why we call it as area under curve. All right, I hope you understand with my explanation. So see you.